transformational technology, and inspirational leaders. I'm your host, Connor Sherman, and this is the Confident Defense Podcast. And welcome back to another episode of the Confident Defense Podcast, where every week I'm sitting down with VCs, CEOs, and security executives to have these honest and real conversations about how we as leaders in security can lead and win. And today is no different. We're in for a really amazing treat. Today we're joined with my co-host, Stefan.
Connor, I'm always excited to be here, but even more so today because you know how important developer security is to my heart and part of how we win.
Exactly. So when we had the opportunity to have Mackenzie on, it was pretty amazing. So just the way of introduction, Mackenzie is a developer advocate with a passion for DevOps and code security. As the co-founder and former CTO of a health tech startup, he learned firsthand how critical it is to build secure applications and robust developer operations. So today, Mackenzie sits as the developer advocate at GitGuardian. Mackenzie is able to share his passion for code security with developers and work closely with something that's near and dear to my heart, the research teams that show us how malicious actors discover and exploit vulnerabilities in code, and specifically something we're going to dive in today, secrets that end up in our code repositories. Mackenzie, welcome to the show.
Thanks, Connor. It's great to be here. That's a great introduction. I feel like I should carry around next time I meet my girlfriend's parents or something. You can introduce me that exact same way.
May I introduce you too? Exactly, yes. I'll just walk into the rooms in front of you. It is well-deserved because you and your team are doing something really incredible. And one of the things I came across GitGuardian about this time last year. I was looking to solve this problem inside my own organization. How do we detect secrets in our code base? And I said, who better to partner with than GitGuardian? Because you guys have been monitoring every single code commit pushed to GitHub, a public repos in GitHub, since July of 2017. So there's something like you guys have evaluated 50 million developers, you've been looking at all these GitHub things, right? There's 50 million personal and professional projects in GitHub. There's 60 million repositories that were created every single year. You guys have looked at on average, about 1 billion commits a year. And then the last part, which is the disturbing part, you've also found there's a 20% increase year over year of secrets being committed to people's code repositories, which then are publicly accessible. So this is the kind of mind-boggling statistics around secrets ending up in our code base. And just for context for the audience here, if you think like, oh, why is this important? Well, secrets ending up in repositories and then adversaries exploiting that led to the breach for Uber in May 2014, Starbucks for January 2020, Equifax for April 2020, and the UN had a breach in January of 21. So this is recent, this is happening, and this is a huge problem. So Mackenzie, let's talk about secrets in code. Can we just start with the problem? Where are the risks? What can go wrong when a developer accidentally commits their secrets to their code base?
Yeah. It's such a fascinating topic. One of the key risks with secrets, and one of the areas why this is so problematic, is the barrier to entry for an adversary is extremely low when it comes to secrets. And it's incredibly difficult to find someone that's properly authenticated in a system. So, when you think about these kind of brute force attacks or other adversaries that are coming in, there are alarm bells that go off when an attack happens. But when it comes to secrets, you correctly authenticated yourself. If there's no other kind of zero trust implications in these systems, then you can go undetected for a long time. You can elevate your privileges, you could move laterally, and you can do a huge amount of damage. And all of this can be done with a fairly low level of sophistication. So, which makes it so problematic in that sense.
So I think that's a really interesting point there. So this idea that this low barrier to entry, it's like you kind of left your keys in the door and then walked away, and then we're wondering like, how did someone get into my house? It's like, yeah, because you left the keys in a place you can find it. So let's give ourselves a little bit of context here. So for technology leaders who are just trying to get there, maybe they're in organizations that aren't so code reliant, or they're just getting their head kind of coming up into the ranks and have to solve this problem for the first time. What does it mean to have a secret in code?
Okay. So, I mean, when we're talking about secrets, we're talking about digital authentication credentials. So, like, typically you can think of these as API keys, security certificates, kind of private keys, or credential pairs, access to your databases. And they can also just be credentials to your systems. And I mean, we're at this crazy challenging area where in modern software development, that if you go back a while, we used to build monolithic applications where we used to build these kind of huge systems and everything ran internal. And now we can leverage this kind of distributed architecture where we have these microservices. So, I mean, take your application. If you're building a Django application, you have Django keys. You've got a Mongo database, you have database credentials. If you want payments, you have Stripe credentials. If you want search, you have these Algolia. Or you want good authentication, then you might use Okta or Auth0. And all of a sudden, your application is this collection of secrets. And this is awesome because it means we can build quickly. And that typically the systems that we leverage through these secrets, if we're talking about external secrets, then these systems are quite robust, so we can have our applications more secure. Yeah. But developers need access to these secrets to perform their jobs. In like kind of your DevOps teams need access to your infrastructure secrets. So if you're hosting on AWS, your AWS keys, etc. And so these are the crown jewels of your organizations. They need to be widely protected, yet at the same time, they need to be widely distributed amongst everyone that needs them. So this creates this huge problem, and it is kind of what we call secret sprawl, in the sense that, like, do you know where all the copies of your secrets are? On what machines? Are they in your Git repositories? Are they accidentally in your Docker images? Are they in secrets.txt on someone's machine? Were they backed up into your cloud drive? Are they on your wiki? Were they shared between developers in your Slack channel? Yes. And the answer is that, like, you can't be sure that they have.
Is there an all the above option that we can?
Yeah. I mean, exactly. It's so hard. I mean, and remote working, we've moved away from these secure services and everything. And I think one of the challenging things with secrets is that there can be this temptation not to handle them really not to handle them as sensitive as they truly are, in terms of, okay, our Git repository is private, let's put them in our Git repository. And then you end up with all these secrets in here, but that's an incredibly insecure way. You've got no access logs. There's no way of knowing where those secrets have ended up.
I think that's part of the problem as well. I think it's the sprawl. I love that word sprawl because it's quickly, I always just think of something out of Stranger Things, the TV series, where this thing that, like, the arms keep going out and growing out. It's just like, you have this sense of, like, the minute you take, effectively, it's just a text string, right? It's just a long, randomly generated character, and that's your API key. But we all know how easy it is to copy and paste a piece of text. So now just programatize that, and you end up with your secret all over the place. And I think there's a really interesting story here. Codecop, right? I think if you could just dive in and give people what's going on with that particular data breach, that really highlighted just the risks that are around when your secrets are in your code base, and how the adversary is starting to think a little differently about this.
Yeah, this one is so interesting because you kind of got secrets all over the place in different areas in this particular attack. So really, what happened with Codecop? So if you don't know, Codecop is a code coverage tool. Essentially, it checks how much of your application is being tested, and so it sits in your CI pipeline, and it kind of sits here, and lots of customers use it. It has about 20,000 active users that are using Codecop. It's quite a popular tool, and essentially it's quite a cool tool too. Like I'm a user of Codecop myself, but what happened was they had a Docker image, and Docker images can be a bit of a blind spot when it comes to secrets, because Docker image just has extractable information, just like a Git repository does, with layers like similar to history. And inside this Docker image, there was a credential that gave access to their Git repository. And an adversary was able to access that Git repository and update one line of code in a bash apploader script. And essentially what that code did is it said, when people are using Codecop in their CI environment, take all of the keys that CI environment is using, so all the environment variables, and send them to the adversary.
So let me get this straight. So Codecop says, hey, come use our product. To use our product, use our Docker image. all of these customers bring down this Docker image and on they go, including the adversary. And in that, they extract the API key. The adversary then logs into the Git repository of Codecop, introduces malicious code. Everybody else in all the customers do their update. They download the malicious code, and now all those customers have their keys in their environment shipped back to the adversary.
That's exactly right. And there can be lots of different keys that are in this CI environment. I mean, typically you don't want to have too many production keys in there, but of course it can happen. But what the adversaries were really after, and we know this from the attack path that we saw, is that they were after other Git credentials. They were after Git credentials that basically gave access to private Git repositories. And once they got into those private Git repositories, they were then searching for more credentials in this to be able to move laterally. And the companies that were affected are massive companies. Monday.com was one, Rapid7, Twilio, even HashiCorp, all released statements about how they were affected from this breach. So you can just really see this kind of sprawling problem of secrets in so many levels. You had a secret in a Docker image that gave access to a private Git repository, and then you're stealing secrets from the CI environment, and then you're looking inside private Git repositories for more secrets to kind of move laterally into these systems. It's like
and just to make it even worse, like a lot of people have like these master keys in their CI pipeline. So like they have the master key that goes to the secrets management tool to figure out what secret needs to be injected at runtime. So I must give the adversary some congratulations on some how do we make our life simple thinking. And it's very 4-hour work week kind of mentality from the adversary here.
Well, and you can, I see this line of code that's in there, and it's kind of like, it's quite elegant. There's this one line of code. There's about 2,000 lines of code in this bash uploader script, and you could just see by looking at this, and the script was just kind of like, ugh, and you just wouldn't have questioned this one line of code had you seen it. It's so simple, and then when you actually look into what it's doing, then quite remarkable.
So in a chance that we were looking at secure or insecurity through obscurity at that point.
Yeah, exactly. I mean, this was definitely an obscure document that it's kind of one of those documents that it's not sexy, right? A bash uploader script's not a sexy kind of piece of code that someone's working on, and you can just imagine that you've probably got the 5th guy working on this that's just kind of, if it's not broke, don't fix it mentality, and someone's just added in a line of code.
All the tests went green, and so we said good to go.
Exactly.
So speaking of that, along that route, we've got some really, really tough problems here, right? Where we've got effectively people, bad people targeting directly at developers. On top of what developers have to do, the mountain of work that they have on the daily basis of keeping the grass green and the lights on and building a mountain at the same time, because that's part of the responsibility. And that mountain is getting code and pushing it to production. So let's talk a little bit about, as they're building that mountain, the impact of the difficulty of building that mountain. And we've talked about the complexity of it. But let's jump into something more tactical, like env files, and what that does to really impact their ability to build the mountain and then secure this mountain.
Yeah. So I mean, it's such a good point. Like the .env file, like the file that pretty much contains all your environment variables to be able to build your application. And I mean, it's such a challenging thing with secrets because how you handle secrets, like as a developer working on a personal project, and how you handle them as an organization is so drastically different that at no point does someone kind of say, okay, and now we do this, and setting up something like HashiCorp Vault is so intensive and cumbersome that you're not going to do it unless it's absolutely necessary. And when you have these .env files, the difficulty thing of it is that that's really how you should handle your secrets for the majority of the projects that you're working on. You put them in a .env file, you try and protect that .env file, and then it gets pulled in by the project that you're using. But the problem is that now you have this single point of truth for all these secrets that adversaries are definitely looking for, that can easily end up in places it's not. Just a simple git add all command captures your .env file. You don't have a git ignore file in there, and now all your secrets are in your Git repository. So, I mean, it's just such a complicated topic to talk about. How do we actually manage these secrets properly? What are we doing at each point, and also understanding how sensitive these files are.
Now, for the listeners, could you just walk through the git add.all through that period, so that way everybody gets to understand what that is? Because I know we have many listeners that don't understand that
Right.
portion of Git.
So when we're using Git, I think we can go into an interesting kind of talk around Git here. But so when we're adding Git, what you want to do is you want to add in your individual files. And so by doing this, you kind of the equivalent of saving. You in your CLI or your Git control, you basically add these files in that you've made changes to, and then at some point you commit these into your Git repository. But as you're going, what it can be tempting to do is if you've been working all day, you've made changes to 40 different files. You don't want to have to type each one into them. So you can go git add dot or star, and basically it's anything that's changed added into my stash. And so this can really quickly capture all the files that shouldn't be there. Now, the files that shouldn't be in your Git repository, so they can be, you might have debug logs. Debug logs often contain secrets in there. Maybe you've saved your bash history because you want to, go back to go back to different areas. Bash history can contain secrets. If you've added an environment variable, shouldn't be in your Git repositories. Or encryption files like .pem. So all of these can be quickly just captured by a single command, added in, pushed up to the repository, and once they're there. And the challenging thing about Git is that once they're there, it's really hard to properly remove them. Because if you delete them, commit it again, they're still there. They're just buried.
So with that, let's talk about the .git ignore. So that's one of the things that I've talked about quite a lot. But the landscape around that too has changed. So where do you think that falls in?
So, I mean, the .git ignore files are just vital. It's something that's so easy to do, and I think, and we're talking about kind of like developers, things that we can do as developers early on and educate them. I mean, like when I talk to junior developers, it's all about implementing these simple practices. So a .git ignore file is basically a file that says if any of these are committed into our Git repository, we're going to ignore them, and they're not going to be pushed up into there. So obviously you'd have your .env file in there, but project specific sensitive files, and GitHub has awesome templates that you can download.
Yep.
And you can add them straight in there. And so this is something that as developers, we need to get into the practice of always doing this. And as an organization, we should always have .git ignore files in there, and we should be alerted if they're not there, because it's just such a simple line of defense that's effective in counteracting this huge amount of sensitive information. In fact, on our state of secret sprawl, it's a huge amount of the secrets that we find are in what we'd call forbidden files. And these are files that would be ignored using a simple .git ignore file.
And using .git ignore is so easy. It's not like like we're teaching a new abstract concept. It's here's a .env, a PEM. We just put it right there. Maybe it's a list of API keys and a text. And we say, hey, that thing, and then that's it. Like it's literally that easy. And you could take your your engineer or your developer that's been working on learning Git or learning how to get code into prod, that they've only been doing that for 6 weeks, and you could teach them .git ignore and start building that maturity level in so early, and then it becomes part of their rote memory process. Not write memory, but like rote practitioner muscle memory. I'm a huge fan of it.
And it gets to the point where it just feels like which feels alarming, and it kind of got tingles if you don't have a git ignore file in there. You kind of it's like, oh, I don't.
You're coding dangerously, friend. Coding dangerously.
The equivalent of not having brakes in a car.
It's exactly true, and it's so, and I mean, like, this isn't going to solve all the problems, but I mean, it's just such a simple thing to do, especially when, look, we're developers. I'm a developer. We're gonna cut corners sometimes. Like, if you if you take all the developers and ask them, okay, can you repeat what our security policies are? I don't know how many would be able to accurately tell you all the information in there, especially if something's cumbersome. So we need to really kind of enforce these good practices. And when there's something so easy as a git ignore file and showing them how effective it is, then it's a huge win.
Thank you for that. And there was one other thread in there that I really wanted to pull, and you talked a little bit about personal projects, and that line between personal projects and maybe accidentally committing something to the wrong repository. Did you talk through that?
Yeah. This is really interesting, and it kind of covers some, and I think it will probably spark some interesting debate and thoughts, amongst the listeners. Is that let's take GitHub for example. You have one account on GitHub. You use that same account for your personal projects and for your professional projects. So you're working with a company, and so they are using GitHub Enterprise or GitHub Cloud. You'd be using the same account. And this makes it really easy to confuse that line between what's professional and what's personal. And so it can be really easy to accidentally commit sensitive information into a personal public repository that was meant to be for the professional repositories. We see a lot of this. And it can be really easy if you're working on a personal project. You don't want to start from nothing. So if you have an idea, we see a lot of personal projects that are kind of forked from what they're doing professionally. And there's this kind of gray line there, but there can be secrets. And I mentioned briefly the history, and I think Git history is something that we don't really understand enough of as developers. And saying that, if we commit a secret a year ago and that doesn't have an expiration date, we may delete that, we may clean up our repository, and the latest version may be completely current, but that secret's still in there. And if we fork that, or if that repository ends up being public, then that secret from a year ago is going to be visible to anyone that knows what to look for. And so when we're coming from, starting personal projects from company work or anything like this, then we can have a lot of information that even if they clean it up to just the bare bones, we have this, this danger of having something in the history. Yeah. And, to give some data to the number of this is at GitGuardian, we find an awful lot of secrets and we report on these. And with all the secrets that we know belong to organizations, so secrets that we know belong to Uber or, AWS or whatever, 80% of them are leaked on personal public Git repositories. So this is on the repositories of their employees.
Yeah, so corporate credentials ending up in private personal projects.
Yeah. And the reason why it's so high is because organizations have no control. You can't enforce your employee to put in security provisions on their personal projects, and nor should you kind of be able to. You're overstepping that line. But there is this blurredness between what you're doing personally and what you're doing, professionally. And and sometimes it can be completely innocent. We see a lot of examples of employees that maybe in an extracurriculum activity are wanting to build, let's say, a Slack bot, where maybe it's not directly related to the work that they're doing but they're really interested. They have this idea for something that will make work more efficient. So in their personal time, they start working on this Slack bot. And they're using tokens for this that grant access into the professional Slack, into that professional Slack channel. So an adversary can find these and impersonate that person or send messages as the bot, to start a phishing campaign. And so this is a corporate key that's been leaked on a personal account. And, you can really see that person really wasn't, wasn't really doing anything. there's no malicious intent. In fact, it never almost is when it comes to your employees leaking credentials. So it's such a challenging thing. And how do you enforce security policies on your employees? You can't. In my opinion, nor should you be able to, but you can educate them, and you
that's right. I want
can
to get to
monitor
that
them.
education piece, because I think there's something really magical here. You guys have both. I want to get into solving this problem because it is such a prolific issue that you see. We're talking. I mean, anyone here, and I'm going to talk about this towards the end here, can go to the Secrets of Sprawl report that you guys have, the Secret Sprawl report you guys have on the website, GitGuardian.com, and just look at the numbers, right? The millions of secrets that are coming out, or the billions of lines of code that the commits that you guys have looked at to discover that. It is such a huge problem. So you guys have also something really cool, which is this open source project, which is GGShield, which we'll get to. But I want to talk about how do we start solving this? There is this sense of you're right. This culture of security mandating engineers how to do their thing at home is just not going to happen, right? That doesn't work. So how do we solve this problem where both the corporate security teams are protecting the assets that they're mandated with, and the developers are feeling empowered to do their work and work on their projects? And what do you think that line looks like? What do you think we start? How do we think we thread that needle?
Yeah, it's really interesting as to how we do this, because there's so many tiers to this, starting from developer education at a very early stage all the way to what organizations need to do better in order to make this. But I mean, that first tier, we need to really work on that developer education area, and as you said, we capture a lot of secrets at GitGuardian. Not all of them are secrets that give access to massive companies, Amazon S3 bucket. Surprisingly, a lot of them are from junior developers or working on personal projects, and they just don't understand that secrets aren't meant to be in Git or know about it. You start your first Django project, you have Django keys in there, you commit them. Now, that doesn't mean that an attacker is going to be able to use these to perform any malicious intent, but it does mean that there's an education barrier from when that person created that application and no one telling them that there's sensitive information within here, and actually how do we do that? And in fact, most people don't even know how to handle sensitive API keys because we see so much being just hard coded into that source code, which exposes them. So there's this initial barrier right from the beginning of junior developers of understanding what these secrets do. And I think that so much of security is just obfuscated to a point where people, where even simple concepts, it can be daunting to talk about. And so we need to kind of clear out that path of understanding and show, okay, here's how an attacker uses a credential. And one of the experiments I love to do.
Getting out of the abstract, getting down to concrete, show an example. It's here's how it works.
Yeah. And my favorite example is something that anyone can do, is go to canarytokens.org, create a fake AWS key, put it in a Git repository, push it public, and then watch what happens. It takes the first ping you'll get will be in about 20 minutes from someone trying to use this AWS key. And what that also goes to show is because I think a lot of people that security by obscurity, people kind of assume that GitHub is so vast that no attacker. Come on, no attacker is going to be looking at my repository. But what people need to understand is that GitHub has an API. Everything you do is broadcast. People don't have to find you. They just need to watch the stream of information coming in, get a bot to pull out that AWS token, ping to see if it's valid, right? And then at the end of the day, you look at your valid tokens, and away you go. You set up your Bitcoin mine. Whatever you're going to do from malicious intent. Use up everyone's 300 free credits.
It was...
The goal there is not are you now for you? It's go out and see who's attackable, and then find which person is now at that point.
Exactly. Yeah.
It really is as simple as that. It's we do often think sometimes that we are the center of our own universe, and somehow the internet is around us. And it's but really it's not. It's the center of this particular universe is the API for GitHub, and we're just going to control that. It reminds me back in the day when we started having really proficient networking internet scanners. And so, like, the next generation of Nmap and all that, people will be like, oh God, we saw ping on ISP number 1 and ISP 2 and the one they're not supposed to know about, ISP 3. It must be targeted. And the reality is, nope. They were just scanning the internet, and you had 3 ISPs, and they just got caught, right? Because they got to the point where we could start scanning the whole internet. Same thing with our repositories. It's that we have made our lives so efficient that the adversary now has this leg up to look at things at scale. They have the ability to attack at scale, just like we have the ability, if we do it right, to defend at scale.
That's exactly right. And I love that example of the network scanner. That's a great one. I'm going to steal that for sure. Yeah. But it's also.
Go ahead.
No. Go ahead. I was about to ramble on. I think. Cut me off.
Well, rambling is fine. Rambling is fine because we all get something out of it, because there's obviously a story to tell. My question that we wrapped around with was, oftentimes in many organizations, and I've seen this up until even last week, is when we look at the engineer team and the security team, there's often this adversarial relationship, almost like a cat and mouse game of, I have to get this code to prod, I have to meet my timeline. Well, hold on, let's go do this check. Well, that's going to slow me down. So what should be in the developer's control? What should be in security's control? Where do you think that relationship lines?
Yeah, a really interesting topic, because we're now coming on to this idea of DevSecops, like where we need the development team, the security team, and the operational teams to all be in essentially like one team and not opposing each other, and it can totally feel what the relationship can be. So part of that solution is to bring security into the developer's world as early as possible. If you're bringing up security problems when it's time to ship, a big feature, or ship the product, bring it out to production, in my opinion, that's way too late, because at that point everyone's on the time limit of when we need to do. So you've got this automatic friction that comes in there. But if you bring security into the process as early as possible, so we're scanning for vulnerable dependencies right from the beginning in the commits that we make, we're checking for secrets right from the beginning, we're running these check logs along the process, that concept of shifting left, bringing security in early, then we're going to remove a lot of this friction. And it also means that the kids have to play together quickly. It's not, especially in these different these large companies where you might have the ops team on 3 floors above the developers. You don't see them ever, apart from at the Christmas party. But we need to open up those lines of communication early, so that they understand. And also, I think that everyone's job's fascinating when you move past the initial shock of like, it's just too complicated to understand. When you actually start to learn about what operations does, or what the security team does, and you relate it back to your world, then all of a sudden it becomes like this really fascinating thing that you almost want to learn more about. So, I think one of the first things to do is, like, we need to bring security in early. We need to talk to developers about it. We need to run checks on it, and we need to do it from the first commit, and not when we're trying to release.
Well, that's, you touched on a couple of things. Is step one is have a relationship.
Yeah, exactly.
Like, let's go have a conversation. Hey, everybody, here's my copy of Phoenix Project. It's yours now. Here's my copy of whatever. Let's talk through this. Let me share. What are you reading right now? I'll go back and read that, and then we can talk about it. In the vast majority of developers, engineers, security practitioners, product developers, TPMs, I rarely find across that entire spectrum people that don't want to learn.
Yeah.
And if they don't want to learn, they probably want to share.
Especially when you bring down the barriers what you break down what everyone does into relatable, sizable chunks that you can begin with. I don't think that it's reasonable to expect a developer to be a security expert. I do, however, think that a developer can learn and should be interested in the security aspects that really relate to what they're doing in writing secure code. Yeah. And the best way to do that is to bring in a security team, and you have this conversation where they're interested in what you're doing, you're interested in what they're doing. So it's an easy conversation to have, and that's it. if you wait till everyone's behind schedule for them to even talk, well, there's no way that date is going to go well. That it's doomed from the start.
And that's when relationships break down.
Exactly. Yeah. You wait to the
Everyone starts
anniversary.
hiding
Mom and
behind
dad
their
talk.
title and their role. Yeah, exactly.
Yeah.
So let's
exactly.
talk about finding that early, because if maybe there's only one security person to every 10, 50, 20 developers at a company.
Yeah.
If that's the case, and we can't be there all the time, nor should we be there all the time, because then we don't breed
Exactly.
autonomy.
Mm-hmm.
Walk me through GGShield as an option to try to maybe not script me out, but as an opportunity to understand and prevent things before they even get to that first commit.
Definitely, and don't worry, I don't think anyone's scripting out a security team anytime soon. I think if we make it there, I'll be old and quite happy. But one of the steps is educating developers about security, and then providing them a tool for them to be able to use that works in with their flow. Because when you look at the security tools out there, and even the ones that are fantastic, they're complicated, they're big, they're intensive, they're difficult to understand. But if we can break apart some of those security tools and give them to developers in chunks that fits into them, then it works well. And that's kind of what GGShield is all about, where it sits into your CLI tool, so your command line interface, so something that developers are using all the time. And what you can do is, for instance, you can create a pre-commit hook, which basically will check your commits before they get stashed into your, even into your local repository.
So this is
if you have
fixing
a
that
secret
problem of them ending up in your
Yeah.
history. Okay.
Exactly, because once the secret ends up into your Git repository, even if it's private, but especially if it's public, then it needs to be considered compromised, because you just don't know who's cloned it, on what machine is it on, where is the secret going to end up. So then it's done. But if you find it early, then you can block it and prevent it from even getting into that. So you don't even need to call the scary security guys. You can remove the key, fix it yourself, and then move forward. And the best part about it is that I haven't done anything out of the ordinary as a developer, right? I've made my commit as I would have. This tool just sits there, and then I get an alert. I thank my lucky stars. I don't have to have an awkward conversation. Then we move forward. And then we can also add this tool into other areas. So if we're running CI/CD pipelines, we can plug it into there. We can scan Docker images. So if we build our Docker image, we can just scan it. And so it's about kind of creating this frictionless, asset where it educates along with, being useful for developers for the specific roles.
Well, and at that point, we've just made it one more test to pass.
Yeah.
It's just one more green check mark and a series of green check marks before you can push.
Yeah, exactly. Exactly. But the important part, around this is that we get in these checks early. Like a commit shouldn't be something that we're doing once a week or even once a day. It's something we should be doing very regularly. So when we have when you talk about these kind of checks, passes that come through, if we're doing a check on a huge bunch of work and we get all these fails, and we have to go back, we have to try and figure out where these are failing from. We have to communicate and coordinate with the teams. But if we're running a check on the smallest parts of the work that we do, then the developer's just gone, oh crap, that's the API key that I just found, or that's because I just added in that debug log. It's simple. We know where it is. We can move on quickly and we not get bothered by it. But the later we leave it, the later we find this stuff, then the more work that everyone has to do. And we have to call the SRE team, and we have to call the security team, and we have to rotate the credential, and then we have to call my colleague.
Or we could just ignore it and move on, and life is fine.
Yeah. Exactly. Yeah.
Well, I love that, and I love that you've got that in there, and we've got opportunities to coach and teach the next generation and make it something that's consumable for them as they progress in their career.
Exactly. Like you get your commit blocked, and then you say, oh, why is my commit being blocked? It says it's a secret. Okay, what have you done? Oh, you've hard coded it. Let's have a conversation about how we actually handle secrets. and that's and then this is day one of an internship, and then forever, that's they have that experience of knowing what to do, and we don't end up where we need to be taught this lesson after 10 years because we've just become so accustomed to hard coding our credentials because our repositories are private, our app is hidden, and no one's ever going to access our information, which we all know from all the breaches is just never true.
Matter of time.
Yeah, exactly.
Now, you brought up an interesting number there of 10 years. So one of our standing questions that we have on the podcast is, speaking of generating the next generation, one of the questions that we consistently have is, what advice would you have given to yourself 10 years ago?
This brings up some really uncomfortable truths that I don't know if I want to talk about, but
Be as transparent as you choose to be.
I just when I first started, like 10 years ago was around the time where I first started up. We first created this startup that I had called Compago, still around today, which is kind of management systems for healthcare. And we were so focused on building out our MVP and moving forward quickly and getting everything done. And one of the biggest problems that we made in general was that we did a lot of things. We wanted to beat the competitors from the start. So we did 10 things worse than anyone else that did 6, So I feel like there's an issue. And then eventually we kind of figured this out and the product was built up and we had patient customers that were coming. And I feel like this can really relate to security coming back too, because when I think back, I have nightmares about our drive to get something done fast and how much longer it ended up taking us in the long term because we had to go back and we had so much technical debt to repay, by the time we became a sustainable business. So I would really think 10 years ago, I would just say to really focus on building out, breaking the project apart into smaller pieces and focusing on making the core elements really robust, really secure, which includes the processes of actually how we develop and build this product out. Because it's so hard. It's so hard to retrofit security. If it's possible at all.
I'm still holding my breath on it if it's possible at all. You just end up like layering it and trying to make it. It's like, it is difficult. But I really like that. For everyone who's coding, it's like, get your business ready for like one big thing. Like go solve one really intense problem. Knowing that when you've built that core business, those other 9 things that you wanted to solve are like, you're going to mature into them when you're ready, right? Versus trying to solve it at the same time.
And I think that's been really cool is that coming on to here in GitGuardian is that, when you first learn about the product, they do one thing. We detect secrets in code and we do it really well. And that's, and there's a big enough market for that, but we do that, arguably, of course I work for GitGuardian. So of course I'm going to say this. We do this better than anyone.
You should say that proudly. I do agree with that.
Oh yeah. So I do agree with it.
So the next question I have for you is, from your vantage point as both a developer advocate and as a security leader and a voice in this community, what is one innovation that you wish that security and technology leaders would adopt at Broad? So if you could just get one behavior change, one technology adoption, one thing, what would you like to see folks adjust and implement?
I just think that there's such huge promise in implementing zero trust throughout an entire organization, where you don't just rely on a password on a particular secret to be able to authenticate someone. You rely on a number of different things: who you are, what something you have, something that you are, and a phrase that so that we can really just build upon this. I feel like zero trust is the answer to a lot of elements, but it's difficult to implement at scale. It creates roadblocks. But if we could implement this throughout organizations early on, if you're a new startup and you're listening to this, consider implementing zero trust at your early stages of your application and your organization, because it can create such a higher level of security when we're in there. And it doesn't mean we don't need to worry about when our keys leaked, but it just means that we can limit the damage and contain it before it becomes a huge problem.
I couldn't agree more, mate. Like, I'm very bullish on the zero trust, because the simple idea of being able to say, I know what my protect surface is. I know what I need to protect. Like, that is the thing people have been struggling with for a decade, right? What do we actually protect? And then micro-segmenting it and saying, okay, we've got small little we start to isolate these things like the hull of a ship. Then we start to authenticate all of our connections. And then we make sure we're authorized to that set of connections. And then we can monitor those guys. Like, you kind of really build it in. Effectively, you make security very, very small in these little tight things. And I think it's, I couldn't agree. I think if that was the one framework or mindset or architecture, I would definitely give a thumbs up on that for sure. Okay. Well, Mackenzie, dude, we could talk about this stuff forever. You are such an incredible guest. So I do want to see if we can land the ship, though. I just want to encourage every single security leader out here who is listening to this report, go read the report. We'll put links in the show notes for the GitGuardian State of Secret Sprawls. Every year they release one of these. They have the latest on 2021. It's enlightening, slightly scary, but empowering when you have the data. So I highly encourage everyone to go check it out, download, follow that. And then also get going with GGShield, right? It's open source, it's free, it's on GitHub. There's links in the show notes. Jump over there, github.com/GitGuardian and get it deployed. You don't have to roll out through the whole org. Pick a couple of friendly developers to get your own security engineering team using it, and just start small and get rolling. So anyway, with that call to action, I will just say, Mackenzie, thank you so much for your time today. And Stefan, thank you for being an incredible co-pilot as we navigate these waters together.
Awesome.
Always happy to be
thanks
here.
so much, guys. It's been awesome. It's been awesome to chat with you guys. I think this is the most fun I've had on a podcast yet. So I'll be back anytime.
Because you make it easy. Thank you.
Yes, you're welcome to come back for part 2 when we've fixed 6 secrets in code next year. Okay, guys. Until next week, we will see you on LinkedIn, and we will catch you next week on the Confident Defense podcast. Take care.